All right, students. In this video, we'll learn how to multiply rational expressions. A rational expression is a fraction where the top of the fraction and or the bottom of the fraction has an algebraic expression in it. Here's an example of two rational expressions. Here's a fraction, rational expression of the top and bottom. Same here. Our job is to multiply. Now remember, when you multiply fractions, you multiply tops, you multiply the bottoms, you try to reduce. But it's usually best to try to reduce first. There's a trap in these problems though. You're not allowed to reduce this 16 with this 16, or this x squared with this x squared. You're not allowed to reduce when you're part of a difference or a sum. You've got to do some factoring first. Let's see if we can factor the top and bottom of this fraction. I'm going to start with the top. I know x squared must be x times x. Can you find two numbers that multiply to 16? Those same numbers must add or subtract to negative 8. 16 is 4 times 4. If I make them both negative, they'll add up to negative 8. This is a difference of squares. I know a difference of squares factors this way. X squared, x times x. 16, 4 times 4. Make 1 plus, make 1 minus. Let's copy the other fraction. There's nothing to simplify in the top. There's nothing to factor in the bottom. If you like, you can put this x minus 4 into a set of parentheses. Now let's try reducing. We're not allowed to reduce this 16 with this 16 because this is part of a sum and this is part of a difference. But I am allowed to reduce whole factors, any top with any bottom. For example, here's an x minus 4 in the bottom and an x minus 4 in the top. I can cancel that, becomes a 1. With that, becomes a 1. Any top with any bottom. Here's an x minus 4 that matches this x minus 4. Cancel that one, becomes a 1 with that one. Now for my final answer, we'll multiply tops and multiply bottoms. In the top, I have 1 times x. In the bottom, I have x plus 4 times 1 times 1. I'm not allowed to reduce these x's because this x is part of a sum. That's my final answer. Let's try another example. I'm multiplying fractions, so I'd like to multiply tops, multiply bottoms, reduce. I like to reduce first, but I'm not allowed to reduce this 9 with this 27 because the 9 is part of a difference. I'm not allowed to reduce this a with this a because the a's are parts of sums. You're not allowed to reduce when you are next to addition and subtraction signs. Instead, let's do some factoring. Let's start up here. Now I notice that this a does not have a number in front of it. I'm going to put a 1 there. Now I need two numbers that multiply to 12 and add or subtract to 1. Well, 12 could be 4 times 3. 4 and 3 will add up to 1 if I make the 4 positive and the 3 negative. This bottom one's a little tricky to factor. But I know that 44 is 11 times 4. 11 and 4 also add up to 15 if I make them both positive. I can do more factoring here. Two numbers that multiply to 27. Let's try 9 and 3. 9 and 3 add up to -6 if the 9 is negative and the 3 is positive. Now that's a difference of squares. A squared is a times a. The square root of 9 is 3, so that's 3 times 3. Make one plus, make one minus. All right, now let's try to do some reducing. Any top with any bottom. I see an a minus 3 factor here that exactly matches this a minus 3 factor here. Let's let these a minus 3s cancel. They become 1s. Here's an a plus 4 in the bottom and an a plus 4 in the top. Any top with any bottom. Cancel the a plus 4 with the a plus 4. Are there any other tops and bottoms that match? Here's one. A plus 3 in the bottom matches a plus 3 in the top. Now that we're done reducing, we'll multiply tops and bottoms. In the top, I've got 1 times 1 times a minus 9 times 1 is a minus 9. In the bottom, I have a plus 11 times 1 times 1 times 1. Since I'm not allowed to reduce these a's because they're next to addition and subtraction signs, that's it. That's as far as this problem can go. This is how I want you to show your work. Write the problem down, factor all tops and bottoms, reduce, write down your final answer. Let's try one more. Take care of all the factoring. I need two numbers that multiply to 4. Well, that's got to be 2 times 2. These 2's have to add up to a -4, so they're both negative. Two numbers that multiply to 8, well, that's going to be 8 and 1, because 8 and 1 can add up to -7 if the 8's negative and the 1's positive. Let's put a 1 in front of this m. Then I need two numbers that multiply to 42. Well, 42 could be 7 times 6. And 7 and 6 will add up to -1 if the 7's negative and the 6 is positive. $14 will go 7 times 2. And if I make them both negative, -7 and -2 add up to -9. Now let's look for things that reduce. Any top with any bottom. There's an m-7 that cancels this m-7. I see an m-2 in the top and an m-2 in the bottom. Let's let those cancel. No other factors match exactly. So I think we're ready for the final answer. In the top, I have m-2 times 1 times 1 times m plus 6, which is m-2 times m plus 6. Now we could multiply that out, but we're not required to. In the bottom, m-8 times m plus 1 times 1 times 1. That's m-8 times m plus 1. All right, that's beautiful. That's the way I want your work to look. All right, your turn. Go work some problems, and I'll see you later on today.